Okay. So 15.2 is about the same thing we did yesterday, except for its volumes of pyramids and cones. Okay, they're very, very similar to the shapes we did yesterday. This is kind of an interesting one in the warm-up here. It says a cylinder with radius little r is placed into a cylinder of radius big R. And it says, what's the volume of the ring-shaped space between the cylinders if big R is 4, little r is 1.5, and h is 8? Jack, you got this?
Yeah.
Can you tell me how to set it up?
Well, you'll do pi big R squared
Okay.
times 8.
Whoops, let me write a big R. Squared times h. Okay, keep going.
And then that you'd subtract that, the pi little r squared times 8.
Great. So he's actually got a pretty good start on the answer for B. I like that. And then we're just going to plug in numbers, right? So this is going to be pi and big R is 4. So this is going to be 4 squared times the height is 8. And then minus pi times little r squared. So that's going to be 1.5. And then we're going to multiply it by the height, which is 8. Okay, so you could type this into your calculator. It will give you, you could type the whole thing in just like that, and it'll give you a decimal approximation for the answer. So can somebody tell me what the answer is rounded to the nearest hundredth? You have it?
No.
No?
I did it my own way.
You did it your own way. Well, let's see if it's right. You think it's 157.08?
Yeah.
Okay. Zach, what do you got?
345. Yeah, I'm
See,
wrong.
that's what I got.
345. Dane, what'd you get?
Yeah, that's what I got.
That's what I got. But
0.57?
Jack got 330.
Oh my gosh.
Ooh,
Okay.
Jack did it wrong.
Raise your hand if you got 345.57.
Jack did it wrong.
Okay, so that's the right answer. There's something missing on this. Yeah. It didn't provide a unit. So
That's
if
what I
we
was
were to acknowledge that there's a unit on this, what would we put for a label on this? Yeah, we could just do U, or we could say units cubed, right? Okay, so there would be the answer to that. Now, I'm going to pick on Dane because I want to today. Dane, you said you got this part, but didn't do this part right here. Given the fact that, fellas, that Jack said it this way. He said pi times big R squared h, and then minus pi little r squared h. Is there another formula we could write down here? We could write that one down, but do you notice anything that we could do with that?
No.
Do you notice anything that's common to both of them? Hold on. What's that? Okay, so if we have a factor of pi and h in both of them, what could we do with that?
Can I phone a friend?
You can phone a friend. Who do you want to phone?
E.
D. If we've got a pi and an h in both of those, what could we do?
We just make it like pi and then parentheses, capital R minus lowercase.
Okay, so would everybody write this down, please? We're going to write down a pi and an h, and then in parentheses, we're going to do a big R squared minus a little r squared. So let's just check and see if that actually works on this one. If we did it for the problem up above, here's what it would look like. It would be pi times 8, and then it would be 4 squared minus 1.5 squared. So would you type that in your calculator and see if it doesn't give us exactly the same thing?
4 squared minus.
Gives you the same thing? Okay, kind of cool. So this type of thing is used quite a bit in math. What we've done here is we've taken the big thing that we want, subtracted out the piece that we don't want, and then what's left is the answer. And we've got this nice little formula that gives us something that you probably will see again at some point. Okay? All right, would you slide down here? Let's take a look at this. I've got a couple of videos. These are fairly short notes. They're similar to what we did yesterday. Fellas, do we need to move? Okay. So the formula for the volume of a pyramid is 1/3 and then capital B times H. Now remember, the B, that big B, stands for the area of the base. Okay, and the base is any polygon. So it could be a rectangle, it could be a square, it could be a triangle, could be a parallelogram or something like that. any polygon that's used on the bottom, if we can find the area of that, we do the area of the base times the height, and then we cut it into a third. Okay?
Wait,
So I'm going to show you really quickly why it's a 1/3. Come back here. Okay, I'm going to pause that for just a second. Okay, so look at that. So this video I think is about 2 minutes long or so, maybe 2.5 minutes long. So we've got this cube. Okay, better way to describe this: if it were a cube, all three of them would be the same, but we've got a length and a width and a height. So we've taken it and divided it, and those pyramids are all equal in size. Okay, he's done a cube on this one to make it look a little better, and kind of the reasoning works a little easier. As you're watching this, I want you to think about, is this an actual proof? Would this work no matter what? Okay, or are they just kind of demonstrating and illustrating the idea and giving an explanation? There's also a little problem with one of the formulas in here. There's a little error in it. See if you can catch what it is. Okay. It's not a big deal. It still works. Do this. Oh, come on. There we go.
I went way too.
Okay. You can watch it again. We're going to look at a couple of other things in here. Okay. So there's a 1/3 in there. All right. Was that a proof, or was that more of a demonstration or an explanation?
Explanation.
Kind of a combination of the two. I maybe wouldn't consider it a full proof, but it was pretty darn good. Okay, let's take a look at this one right here. This is how easy this is. Okay, the base is a rectangle. So if we're finding the area of that base right here, the formula for the volume is going to be 1/3 b times h. And the base is a rectangle. So this is going to be 1/3. Since the base is a rectangle, we'll do length times width. So this is going to be 5 times 2. And the height is going to be 3. Now keep in mind, all of these are meters. So we're leaving the units off for right now. Does anybody notice something we can do here? Yeah.
There's a 2, 3, so you can.
Yeah, you can cross cancel these, right? So we end up with 10 what? Meters cubed. Okay, so 10 cubic meters. So there's the answer on that one. Okay, this one is a little bit more interesting. I'm going to blow this one up just a little bit. Come on. There we go. Okay, so again, the formula for the volume of a pyramid is 1/3 the area of the base times the height. The base in this case is a triangle. So this is going to be 1/3. Okay, and this is where it gets a little bit interesting. This is the triangle we're using. And we often say base times height on these. Might be a little better in this case to say length times width. So the area of the base is going to be 1/2 the length times the width. So the length is going to be 8. The width is going to be 6. And then what's the entire height of the pyramid? 12. So we put a 12 right here. Okay. Zach, do you notice anything we can do here?
You can take out 6 and
We could take out the 6 and the 12, or how about we take the 3 and the 2 and we do some cross canceling? 3 and the 2 would cancel with the 6. So we end up with 8 times 12, and 8 times 12 is 96. Okay, and this again is a huge one. This is in miles for some reason. So it's 96 miles cubed,
What if I
cubic
did it a
miles.
different way?
Did you get the same answer?
Yeah, I just did 24 times 12.
Yeah,
and then
totally okay. Okay, when we're doing this, I'm just showing you don't need to grab a calculator to get these, because if you were to multiply these numbers together, like the 8, the 6, and the 12, you'd get a pretty big number. Okay, and then you'd have to multiply by the 1/2 and the 1/6. If you can cross cancel, that's going to make things a little bit easier. Okay, so the volume of a cone, 1/3 the area of the base times the height, and the base is a circle. Okay, so on this one, it's a little bit easier. And again, we probably ought to just memorize it this way. The volume is going to be 1/3 of, let's see, the base is a circle. So that's going to be pi r squared times the height. So remembering the volume of a cone as 1/3 pi r squared h is probably better than remembering it as 1/3 the area of the base. But the idea they're trying to prove here is that what we really are concerned about is what is the area, how much stuff can we stack on the bottom, and then how tall can we stack it in order to get the volume. So this means the volume of a cone is exactly 1/3 the volume of a cylinder with the same dimensions. So if I were to draw the cylinder kind of like that, it's exactly 1/3. And I'm going to show you a video that kind of illustrates this. So we're going to come back over here. Okay, and this one is 35 seconds long, so it's pretty darn quick. So that cone that he's pouring water into has the same height as the cylinder he's dumping it into, and it has the same radius. You can kind of see that it has the same radius.
I say this is more of a demonstration.
You say that's more of a demonstration?
I think so.
So there's 2.
Shut up.
You guys are so nice to each other.
Just kidding.
We know.
Wow.
Oh,
That's great.
dude, that looks so good.
Looks pretty
I'm
good.
so thirsty.
Now you're thirsty.
I could
Okay?
get like a quick water.
We're almost done.
Can I get a drink?
Nope.
Huh?
Good try. Okay, so this one is going to be 1/3. Again, please remember this is pi r squared h for a cylinder. So we're going to do the pi. We're going to do the radius here. So that's going to be 3 squared. And then we're going to do the h. That's going to be 10. If you want to, you can type that into your calculator. Can we do any cross cancellation?
I mean,
Cancel here. So we end up with pi times 3 times 10. So throw that in your calculator. Somebody help me out. What do you get?
530.
94.247. Or 94.25.
94.25.
Okay, yards cubed. Okay, Mason, did you have something you want to say?
So if you check this cylinder,
Actually, that's 3.
the area of the shape, the space that is filled around the cylinder would be 2/3 space, right?
Yep.
You really do.
Yep. Okay, take a look at the next one. I'm going to ask Cy for the answer. Everybody go ahead and do B right now, please. Get the answer to B.
Oh, so base is like the radius. Right.
Cy, what do we have to be careful with here?
Radius.
And what is the radius on this one? Radius is 4, okay? So this is going to be 1/3 pi. We're going to do 4 squared times the height of 9. I can do some cross cancellation here, right? So I can cancel that. So this is going to be pi times 4 squared times 3. So that'd be, what, 48 pi? And can somebody help me out with 48 pi as a decimal?
Why did I get 50.8?
150.8? 0.80?
Yeah.
0.80, and that would be in centimeters cubed. Okay.
Tornado.
Yes.
All right. Everybody good?
Yeah.
Okay. So here's a couple of questions. We'll look at this, and then you will run into this idea later down the road. Would it matter if the cone or the pyramid was oblique?
Like slanted.
What is, okay. So oblique means slanted. Okay. Would it make any difference? Yeah.
No.
It would not. Okay. So it's not going to make any difference. Okay. And can you explain why you answered the way above? Why is the answer to this no? Why would it not make any difference? Luke?
Because it doesn't make any difference with cylinders. So why would it make a difference with cones?
I like that argument. Somebody want to do another argument?
The actual amount of stuff there, like if one line grows more, the other one shrinks the same amount for it to be so it's the same.
I like that. Anybody else?
Imagine you have a cone and then it's like made out of Play-Doh and you push it and it still has the same amount of stuff.
Ooh, I really like that idea. Okay. So imagine if you had a cone or a cylinder and it was made out of Play-Doh and you just pushed it over, it's still the same amount of stuff. We're going to look at that a couple different ways. So one more video. This is called Cavalieri's principle. Yep.
The same. Yes.
They're the same.
That's the same. The cats.
And
8 pies.
Okay. So all we need to be careful of is that we're truly using the area of the base, and then we're using the vertical height, not the slanted height. As long as we're careful about that, then we'll be fine. I want to show you one more quick demonstration just to kind of convince you. This is a ream of paper, so there's 500 sheets of paper here. So the volume is not going to change. So Lizzie's argument of if we had Play-Doh and pushed it over, you can do the same thing with paper. So if I take this and make it go like that, it's a different shape now, but it's still the same 500
How do you
pieces
do
of
that?
paper.
Wait, what?
I don't know how to do that.
No.
So you just let it drop and then grab this side and it'll spread out even more. Take a look at this.
How?
What?
How
Okay, we're gonna do a sphere.
See?
Wait, go straight and then do it.
My mind hurt.
Now do a sphere.
Yeah, if you do it all the ways, could
This,
you make it like a
reminds me,
circle?
crew, at some point, we're going to have to make sure everybody can draw a 3D box and a cylinder. Okay, so
Dude,
it's,
I
it's like
practiced
this.
yesterday.
Okay, all you have to do is let it droop like that. Still the same volume, by the way. and then I'm going to grab this side and hold it together, and I'm going to let go of that side. And then it goes like that. Maybe later. This is math class.
After I get a drink of water.
All right. Okay, back to this. Flip the page over. This is the video link that I just showed you. All we need to do is just be careful that we're using the height of the object from the base to the tip instead of the slant height. Okay, so please don't use the slant height. We need to use the distance from the base up to the tip. So we'll do a couple of quick ones here. It says an animal feeder is in the shape of a pyramid. The base of the tank is a rectangle with a length of 2 feet, width of 6 feet, and a height of 5 feet. Find the volume. So because it's a pyramid and the base is a rectangle, all of these have that 1/3 in them. So this is going to be 1/3 of. The area of the base is going to be the length times the width. The height is just going to be the height. So we're going to be 1/3. Let's see, the length is 2, the width is 6, and the height is 5. Can we simplify this at all? Before we type it in a calculator, do we need to worry about the third? Don't think we need a calculator because I can cancel the 3 with the 6. That's going to be a 2, so we end up with 20. Okay, so 20 cubic feet.
Like, I didn't think we needed a calculator, even if you didn't.
Okay, probably true. Okay, right circular cone has a slant height of 26 inches and a radius of 10 inches. Find the height of the cone using the Pythagorean theorem, and then find the volume of the cone. So we've got this.
Oh wait, it doesn't. Oh my, it's so dumb. Freaking Mr. Laws, this is why I hate
Slant height's 26, right?
But it doesn't matter.
Let's see.
It doesn't matter that it's not. Yeah, so dumb. He's trying to confuse us for no reason.
Well, you stop complaining.
No, it does make a difference.
Wait, is the thing straight?
So here's what's interesting. So I have not done this problem before, but the radius is 10 and the slant height is 26.
But the diameter is 20.
It says, okay, so we're gonna change this. So it says use the Pythagorean theorem. We do need to find the height from the base up to the tip. Yeah.
It says it's a right circular.
Oh, right circular cone.
So it
Okay.
doesn't matter.
Well, you could use the Pythagorean theorem and use the
Oh, it's not
slant.
an oblique one. Here we go.
It doesn't
Okay.
matter. So
This, okay,
Wow.
we're okay with this. Hang on one second.
That's
Thanks
a
for
lot of
catching that.
lines.
It's not oblique, it's right. So this is 10 and this is 26. We're not going to use this 26, but we are going to use the Pythagorean theorem to find the actual height. So I'm going to use an H right here. Okay. By the way, can somebody remind us what the Pythagorean theorem is? Dane?
Leg squared plus leg squared.
Oh, that makes me so happy. Leg squared plus leg squared equals hypotenuse squared. So in this one, we're going to have 10 squared plus h squared equals 26 squared.
That's a big number.
Correct me if I'm wrong. 26 squared, is that
676.
676?
And then you subtract the 100 from it, you get 576, and then you get.
Ooh, that's
24,
nice, isn't it?
And then you get 10 to the 24th
I
square
think
root.
I think Mr. Laws knows.
Square root of
how to do
576 is 24, right?
Yes.
Okay. So h equals 24. So now we can use the formula.
Cross cancel.
Because we can't use the slant height, we use the actual height. So the distance from the base up to the tip. 1/3 pi r squared h. So 1/3 pi times 10 squared times 24.
We cancel.
And you can do some canceling and all that sort of stuff.
Does it matter though, because it's just like a calculator?
We are going to end up putting it in the calculator, but it should be the same as 800 pi, right?
Yep.
And somebody give me a decimal for that.
Whoa, what just happened?
25174.
Say that again.
No,
2,500.
2513.27.
2,513.28
What?
inches cubed.
27.
2.7
Luke.
inches
Oh, my bad,
cubed.
I didn't round.
Okay, we good there?
No,
Okay.
I rounded bad later.
All right. Volume of a cone is 36 pi cubic units and the height is 4 inches. What's the radius of the base? Okay, Luke, I don't want you to tell us the answer. What's different about this problem?
It gives us pi, so you don't have to divide it. We've got pi as a variable in the equation, which means that you can just divide it by pi easily by removing it.
Kind of.
No.
Kind of.
That cancels out, so it's like.
What's different? Yeah.
We're finding the radius.
We're finding the radius, not the volume. They give us the volume right here. So here's the volume. Okay, here's the height, and what we're finding is the radius we don't know. So if the formula is V equals, and it's a cone, 1/3 pi r squared h, this is going to be 36 pi. This is 1/3 pi. This is the radius squared, which we don't know the radius. So we're going to use r squared, and we know the height is 4. Now we can talk about what Luke was talking about. Luke, what can you do on both sides? Cancel out the pi. Divide both sides by pi. So here's what we get. 36 equals, if I write it this way, multiply both sides by 3 and divide by 4. Multiply by the reciprocal.
27 equals R.
Whoops. So r squared equals, let's see, this is going to be a 9. So that's 27. And then crew, how do I undo squaring?
Square root. Take the square root.
Well, thank you very much. Take the square root of both sides. So r is equal to, since that's 3 times 3 times 3, that's going to be 3 radical 3, or as a decimal, 5.2. Okay? And that would be in
Inches.
inches.
Not
Okay.
squared or.
All right. Now, would you take a look at that last problem right there? I'm going to pause the video.